A robot that instantly understands you, perceives the world as you do, and effortlessly interacts with objects it has never encountered before, without the need for training or coding. This isn't science fiction, it's the reality Figure's new Helix AI is striving to create, potentially marking the most significant advancement in home robotics yet. Just a few weeks ago, Figure officially ended its partnership with OpenAI. On February 4th, Brett Adcock, Figure's founder, took to Twitter to confirm the split, stating that his company had achieved a groundbreaking in-house breakthrough in fully end-to-end AI for robotics. That breakthrough is now known as Helix. Shortly after this announcement, reports surfaced that Figure was in talks for a massive new funding round, $1.5 billion at a staggering $39.5 billion valuation. This level of investment suggests that investors have already witnessed something game-changing. And honestly, who wouldn't be excited about robots capable of seamlessly putting away groceries? So, what exactly is Helix, and why is it such a big deal? The name Vision Language Action provides a clear hint. It integrates three essential components. It sees the environment, vision, understands commands, language, and executes tasks, action. Unlike traditional robotics, which rely on pre-programmed actions for specific tasks, Helix is a generalist model. This means it can handle a vast range of household objects without requiring extensive demonstration data or individual coding for each item. In one of Figure's demonstration videos, a person simply asked, "Hey, can you two robots put away this bag of groceries?" The robots scanned their surroundings, opened the fridge, sorted the items accordingly, and even placed an apple into a fruit bowl. What's even more impressive is how these robots work together, seamlessly passing objects between each other without any complications. Brett Adcock revealed that his team has been developing Helix for over a year with the goal of achieving truly general-purpose robotics. Helix doesn't just recognize objects, it reasons through problems, responds to voice commands, and interacts with new items it has never encountered before. This level of adaptability is a game-changer because the average home is far from a structured assembly line. Households are unpredictable, objects are scattered, lighting conditions vary, and every home presents a unique challenge. For a robot to function effectively in such an environment, it needs to be highly flexible, a quality that has long been missing in robotics. One of the standout features of Helix is its dual-system architecture, known as System 1, S1, and System 2, S2. S2 is the slower, internet pre-trained vision language model. It is responsible for interpreting natural language instructions, analyzing the surroundings, and generating a general plan for execution. S1, on the other hand, functions as the fast visual motor policy that converts the plan into real-time physical actions at an impressive speed of 200 Hz. Think of S2 as the brain that steps back to analyze and reason about the task, while S1 acts as the nervous system, handling quick and precise motor control on the fly. Both systems operate directly on the robot's low-powered GPUs, which means Helix doesn't require a massive external computing setup. This makes it commercially viable from the start, without the need for an expensive, high-powered server. Figure claims that this dual-system approach effectively solves a long-standing trade-off in robotics. In the past, large language models were great at processing instructions, but were too slow for real-time physical control. Meanwhile, smaller control policies were fast, but limited in scope. By separating Helix into S2 for strategic reasoning and S1 for rapid execution, they've managed to get the best of both worlds. To train Helix, Figure built a dataset consisting of roughly 500 hours of teleoperated behaviors. They then used an auto-labeling vision language model, VLM, to generate natural language instructions for each training example, making the dataset align with how a human would typically give commands. But that's just the beginning. Helix also introduces several groundbreaking innovations in robotics. The first major breakthrough is full upper body control, boasting 35 degrees of freedom across the wrists, torso, head, and fingers, all running at 200 Hz. This level of coordination is crucial for tasks that require handling various objects, especially when opening a fridge door while simultaneously adjusting its torso position to look inside. The second major breakthrough is multi-robot collaboration. In one demonstration, two humanoid robots successfully passed grocery items between each other using nothing but verbal instructions. Commands like, "Pass the bag of cookies to the robot on your right," were executed flawlessly. "Pick up anything emergence." Because the system integrates large language understanding with visual processing, it doesn't need specific training for every object it encounters. Instead, it can handle thousands of different household items based solely on voice instructions. For instance, if you say, "Pick up that weird plastic dinosaur," Helix can figure out what you're referring to, even if it has never seen that object before. This level of adaptability is rare in robotics and eliminates the need for extensive retraining for new tasks. Helix also takes a unique approach by using a unified neural network instead of multiple separate models for different tasks. It relies on a single 7 billion parameter vision language model S2 for high-level reasoning and an 80 million parameter transformer S1 for precise motor control. This single set of model weights enables Helix to control its entire upper body, performing actions like picking up items, placing objects, opening drawers, and even handing things to another robot, all without requiring additional fine-tuning for each new task. Finally, what makes Helix even more practical is that it's designed for real-world commercial use. Since it runs on embedded GPUs, there's no need for a bulky external server or a constant internet connection. This means the robot can move freely around a home without being tethered to a massive computer setup, making it a true step forward in home robotics. It also means the system operates faster and with greater security, reducing the risk of random latency issues if the internet goes down. However, it's important to remember that this technology is still in its early stages. If you watch the demo videos released by Figure, everything appears seamless, but that's likely the result of extensive behind-the-scenes testing and optimization. Realistically, we're still a few years away from seeing these robots cooking full meals, folding laundry, or vacuuming an entire house with the same efficiency as a human. However, Figure is positioning Helix as a revolutionary leap that can scale from industrial applications, where they've already collaborated with automotive companies like BMW, to real home environments. Interestingly, Meta has been reported to be building a new division dedicated to AI-powered humanoid robots, while another robotics startup, Apptronic, recently secured $350 million in funding with backing from Google DeepMind. There are even rumors that Apple might enter the robotics race. This suggests we're witnessing an emerging robotics arms race among tech giants, each striving to shape the future of humanoid robots. TechCrunch journalist Brian Heater has noted that many humanoid robotics companies focus on industrial and logistics tasks first, such as moving boxes in warehouses, because these environments are structured and predictable. However, Figure is taking a different route by prioritizing the home environment, an inherently chaotic and unpredictable setting for robots. In a household, people move furniture around, spill liquids, leave laundry half-folded, and create constantly changing conditions. Solving these challenges would mark a major breakthrough, as it would naturally address a significant portion of the broader challenges in general-purpose robotics. Despite this home-use pivot, Figure hasn't abandoned industrial applications. Instead, they view home environments as the ultimate testbed for adaptability. If a robot can handle the complexities of a home, navigating messes, interacting with random objects, and adjusting to spontaneous changes, it can likely perform most industrial tasks as well. Bridging the gap between factory floors and everyday households has long been a challenge in robotics, as the technical requirements differ significantly. Helix's approach sidesteps traditional methods of either hard-coding every action or requiring robots to be trained on thousands of identical demonstrations. Instead, it leverages a vision language model, VLM, to develop a form of everyday common sense, understanding how a fridge door opens or where apples are typically placed in a kitchen. S1 then refines the execution, ensuring that the robot doesn't require extensive retraining every time it encounters a new object, such as a mug or toy. This method represents a potential step change in robotic capabilities, aligning with Brett Adcock's vision for the future. Of course, major questions remain regarding safety, reliability, and the potential risks of hacking, which will need to be addressed as Helix moves closer to real-world deployment. You might be wondering, can someone hack my home robot and make it do strange things? That's a concern we may hear more about as the technology evolves. For now, Figure is primarily focused on perfecting Helix's core AI, ensuring it can quickly generalize tasks and adapt to new situations. We're also seeing a strong emphasis on user-friendly features, voice commands in natural language, a single system capable of handling unfamiliar objects, and the ability for multiple robots to collaborate seamlessly in real time. According to Figure, Helix functions much like a human. It understands speech, reasons through problems, and manipulates objects as needed. While not everyone is ready to bring a six-figure humanoid robot into their home, mass production could eventually drive costs down, making these robots more accessible. In the future, we might see them in service industries, elder care, or even as advanced household assistants. So, what are your thoughts? Would you trust a humanoid robot to navigate your kitchen, or do you think we should wait until the technology becomes even more reliable and affordable before letting a machine grab a glass from your cupboard? Let me know in the comments. Thanks for watching, and I'll see you in the next one.